right, guys, so with function operations.
And then, what about
The domain we have to be able to evaluate when we do operations with our functions. So the domain of the new function contains those values common to the domains of the individual functions. Question. So guys, what this is talking about with function operations, like if you're adding or subtracting two functions, whatever the two original domains were, you're looking for what overlaps with those two. And that's your new domain of this combined function. So if they both start all real numbers, your new combined function is all real numbers. That's pretty straightforward. But if one has restrictions, those carry through into your combined function domain. Okay? And we'll do a bunch of examples with it. Finn, are you okay? Did you get that squared away?
Yeah.
Okay, good. All right, so I'm going to give you a couple of functions and we'll do a bunch of stuff with them. So first, f of x is equal to x over x minus 1. G of x is equal to x squared minus 1. Part A, we're going to find f of x plus g of x. So I'm just going to write the f of x function, the x over x minus 1, plus x squared minus 1. Okay, can I just add those nicely? No, what do I need? Common denominator. Yeah, you can think of the second one, put it over 1. And then what would I need to multiply both numerator and denominator of that fraction by? X minus 1, good. That's your well-chosen one there. So then we're just going to simplify. So I now have x, and then if I multiply this out, I'll have x cubed minus x squared minus x plus 1 all over x minus 1. So what's my final simplified answer there? What am I left with?
X cubed minus x squared plus 1?
Yep, over?
X minus 1.
Good. So that's the actual combined f of x plus g of x. And then you're also going to tell me the domain of this combined function. Anybody have any thoughts? Is there anything x cannot equal here? Yeah, go ahead. X cannot equal 1. And guys, could we figure that out way up here, like from f of x? Did we know that x could not equal 1? Yeah, so we know that's going to carry into this domain. We can see it again in the answer of the combined functions, but x cannot equal 1. We can never divide by 0. So when you're looking at domain, you can't divide by 0, and you can't have a negative number under your square root. Those are really the only two things you have to think about with domain. So we'll write it with interval notation. We'll say negative infinity to 1, union 1 to infinity. So just skipping over the 1. Questions on part A? Okay, part B, let's try f of x times g of x. All right, guys, so multiplying these, you're just going to write x over x minus 1 times x squared minus 1. Okay, you could distribute your x, multiply. Remember with fractions, multiplying, it's just numerator times numerator, denominator times denominator. But could we simplify before we multiply here? Yes. Okay, good. You guys see it. What does x squared minus 1 factor into?
X minus 1.
Good. I'm just going to put that all in the numerator. I wrote that kind of weird, but you get the idea. So what can I get rid of? Yes. So my answer, if I distribute, I will have x squared plus x. Okay, what about the domain? What is it? It is the same, yes. If you look just at the answer, what does it look like our domain should be? Yeah, it looks like all real numbers, but we know we have to think back to those original functions that we started with. So look at your first step. If there's anything that x cannot equal in that first step, that has to be noted in the domain. So again, it is negative infinity to 1, 1 to infinity. Okay, one more with these functions. We'll do division. F of x divided by g of x. You guys try this one. We'll see how your algebraic skills are with fractions. with each other. Guys, I take either of those answers for this one. Okay. Yeah.
You do X or X minus 1.
Yes, absolutely. Yep.
Oh, yeah.
You could write it fully factored. That way it's nice because then you can truly see what your domain restrictions are going to be. So guys, what can X not equal this time? 1 and -1. Yeah, so we've got negative infinity to -1, -1 to 1, 1 to infinity. We do okay on that one? Okay. I see some faces that look like they have questions. You sure? You didn't get it? Okay. We're okay, like you understand this is just writing them divided. Remember, a fraction divided by a fraction, you multiply by the reciprocal. So it becomes x over x minus 1 times 1 over x squared minus 1. So that's how they both end up. It's so tempting. You're like, oh, something should cancel, but it doesn't. Yeah. So if we look at this step, if I factor that denominator, yeah, okay.
Oh, is there so right -1, 1? If there's a gap, is there anything between these?
Yes.
Oh, there's the other one.
Mm-hmm. Yep. Because like 0 would work. You could plug that in. So it's only those two numbers that we skip over. Okay. Other questions? Okay, let's try with new functions. All right, f of x is x over 2x minus 1, bless you. G of x is x minus 2 over x minus 1. I'm going to find f of x minus g of x first. All right, I'm going to give you guys a minute to try that one. A little more work with the common denominator than our last one. Hey guys, we're not going to do a part B, so I don't know why I put part A, but anyway. We'll just call it question 2.
Oh my god. Okay, good. That's it. So it'd be so it's very nice. I make
And then you have to
yeah, you can multiply the bond by that way. Yes, yes. Everything you multiply. So you don't. I just want the rest of everything. What is this?
Yeah.
How would you do it? That's what I did. Please. I did this. Okay, and this is
But nothing's going to change.
that's it. That's your final answer? So every so you got minus 2x. Is that weird?
I like your denominator.
I'm not gonna read that.
Oh, so you're
See, I can find the negative is only when you're subtracting. But you would carry over to something, so look at that. It'd just be this, so it's like, multiply that by that to get.
You're good. You work with your negative and the numerators.
Okay, and then the domain is negative to, okay, so one fraction said you need one, so then move down to your number one. There's all of them, like this way they got it, there's always going to be
Well, okay.
When they point out, there's
With graph.
Oh, with back.
Yes. Other weird graphs sometimes.
Yeah, this was like, yeah.
think about like,
That's not just worry about this thing. I don't have to put commenting on it. The whole point is surveying, you gotta commenting on it.
but like, if you multiply it by
This will be your denominator. Now they know, right? So
Well,
that's
you get the same
you need to
denominator, but they
multiply
don't.
this. Oh, right. Denominator is right.
So what you need to do is, so it's one jack
Whatever they were. Yeah. If you want to simplify it, you what I did was I just multiplied it. I just like,
the denominator would make, because you still need this multiplication, like one is two.
Guys, I'm going to start going through it. If you're still working, that's okay. You need a common denominator here. So the first fraction, I have to take numerator and denominator times x minus 1 from the other fraction. And then the second fraction, I'm multiplying numerator and denominator by 2x minus 1. Again, guys, that's a well-chosen 1. It's 2x minus 1 over 2x minus 1 is 1. So I'm not changing the value of anything. I'm just manipulating all of this so that I can actually subtract the two fractions. Then I get a multiply. Denominator, we're good. It's 2x minus 1 times x minus 1. And honestly, guys, I don't care if you multiply out your denominator. Leaving it in factored form, it's so much easier to figure out your domain from there. But the numerator, I do want you to simplify a little bit because we've got multiplication and subtraction happening. So I'm going to distribute. This will be x squared minus x. Then be careful. It's minus all of this, okay? Which is x squared minus 4x minus 1x, so minus 5x plus 2. Don't mess up a negative, okay? So x squared, oh, 2x squared. There we go. Don't miss a 2, that too. So you should end up with negative x squared plus 4x minus 2. And then again, I don't care, you can leave that denominator factor. 2x minus 1 times x minus 1. How'd we do with that? And then your domain, guys, do you see that there's two values we have to skip over? Okay, so negative infinity to a half to 1, 1 to infinity. Okay, let me stop there for a second and see how we're doing. Did you get it, Aiden, or are you processing right now? Okay. It looked like a deep thinking face, so.
No, just do it formulated.
Let me know if you have questions. Otherwise, I'll just let you think for a minute. Okay, see? You needed a minute.
X minus 1
All right, guys, are we okay on this one? Oh, okay. Pretty good. Starting to see it.
Yeah.
Well, here's the thing, guys. We still have all of composition to get through and inverses to get through. So you'll get to do a little bit more of this with composition, more like common denominator stuff. So we'll try that then, okay? We got a lot to get through today. One of those days. I know. I feel like what we're doing today is like 4 days in Algebra 2, you know? It's all in one.
I like solve a problem and it takes up like half the page. So I'm probably gonna go back to simplify math.
Make it a little clearer for yourself, yes. If we have time at the end, I'll put up another one, okay? I just want to make sure we get through the rest of the stuff. Okay, guys, so that's operations with functions, add, subtract, multiply, divide, okay? We also have composition of functions, which you've seen this before. This is like the f of x, like f of 3, f of g of x, that sort of stuff, where you're plugging something in. That's what we're doing next. All right, so you are given that f of x is x squared plus 2x. G of x is x minus 4. We are going to find f of g of x.
How many more examples for function?
So this is now composition of functions. So
Okay.
we've got 2 of these, one of which is kind of big, and then inverses. A whole page of inverses. We got a lot left, guys. Oh yeah, we'll be fine.
What's the success rate of this class?
Hi.
How many people actually get A's?
Not that many.
So it'll be interesting this year because, like, when you get your assessment back, there's no like A minus, B plus, B minus. Like it's A, B, C, D, right? Do you guys know this?
How about in past? In past.
Like actual A's? There are plenty of people who get actual A's. Not more than 50%. No. Not plenty. More schedule changing.
Yes.
All right, let's try this one. You're used to doing this with numbers. Like if I said f of 3, you'd know I'm plugging a 3 in wherever there's an x in the f function. When it's f of g of x, you're plugging the entire g of x function into the f of x function. So you're taking all of this and plugging it in wherever there's an x. So I'm going to say, and put it in parentheses, guys, x minus 4 quantity squared plus 2 times x minus 4. Okay, and then we're just simplifying. So x minus 4 quantity squared, what is it? Ooh, not x squared plus 16. Yeah, don't forget the 8x in the middle. Because think of it as x minus 4 times x minus 4 again. Such an easy mistake to make. And then we'll say plus 2x minus 8. So your final answer here is x squared minus 6x plus 8. And no, you don't need to factor or do anything with that. We're not solving. That's just your answer.
Okay. That was easy.
That one was easier, right?
Yeah.
We do have to state the domain again. Now, kind of similar to function operations, you start with whatever domain restrictions are on the inside function. So in this case, the g of x. Were there any restrictions on g of x? No. And are there any restrictions on what we came up with at the end? No. So my domain is negative infinity to infinity. All right, that one was a confidence booster, right? We can do that.
Oh, yeah. 100%.
Okay.
Let's just ask them.
Now it's going to get more interesting.
How would you put like x cubed, x, f of x? Oh.
No, I'm just going to give you more fractions.
Oh, oh.
Yes.
Oh,
Everybody has fun with fractions. Okay.
I just like, I remember learning fractions in like second.
I don't know. Just because. All right, and again, we are finding f g of x. I won't just let you flail in the wind on this one. I'll help you, okay? But I'll let you write it first.
1 plus x. I always say that if you have to only
You can write it as
negative x plus 1, right? That's how it is.
you can write it as x plus 1 if you wanted.
No, because like, isn't 1 plus x different as x plus 1?
1 minus x is different than x minus 1, but pluses, they're all positive, so
Oh, okay.
yeah.
Don't be writing it like that.
I'm messing with you.
I smooth my fragile key.
We're in a fragile state here on our last note. Okay, g of x is on the inside again, right? Oh, okay, sorry. Yes, I want you to have it written before I start. No, but some people didn't have it written. I mean, you can if you want to, but I'm going to go through it. Okay.
I'm trying. You don't have to. I got it. You don't have to. There's too many lines, so.
Too many lines. Oh, wait till we put the fraction in the fraction. And then... Oh, okay, yeah, there are a lot. It's like 4 tiered fractions. All right. Are we ready, guys?
No. I want to try to solve it.
Oh, I thought I was helping you.
No.
You want to try it?
We're probably
I'll show you step 1 for those of you that are very nervous. And then you can try from there.
okay.
Oh, is it 1 plus x? Is it plus x? X plus 2 will be next.
Oh, 2 over 1.
That I
Yes, put your 2 over 1.
Makes it easier.
Oh, but I can only use x.
Is it 2?
You got it? Let me check.
Like I'm literally on the brain.
So, I put it up like this, and then when I like, put the multiplication, do I do x minus 3 over 1? Or,
You need to simplify your denominator first to 1 single fraction, and then you can do...
so I would simplify this into one fraction. How would I do 1 plus x times 2?
What do you need to add?
So I would multiply this, the top and bottom by x minus 3.
It's always top and bottom.
I got it right.
I don't like when you have... You need to combine this. Or are you doing it first?
I know this.
We have to simplify before I do it.
So everything else. Alright, is this correct so far? Wait, so.
Okay. Oh, we got the same answer. Really? Oh, you make me think I got it right.
Yes.
Yeah, I got it right.
No way.
1 plus x is the same as x plus 1. But 1 minus x is not the same
You got it right. Wait, is it?
Oh!
What did you get first?
Oh, I see it, I see it, I see it. What? I got 1 plus x plus 1.
Yep, that's what I got.
Yeah.
I don't know if that's right or not.
Now I'm starting to remember.
I didn't check your domain, but you're.
Where is the?
I know.
Now we're at the
If I got this, it's not 1 plus 1 and 3 x. It's right.
Yeah, make sure.
Wait, so I so what I did is I don't know what
All right, guys, let me go through it. You made excellent progress. Make sure you simplify this denominator before you start flipping and multiplying things.
Yeah, I What is that? What? That's not the answer.
if I got this
What? I'm going to simplify and flip all at once here.
It's the smart way.
I can multi-make.
It's x plus 1, 3x minus 1.
And yeah, you can say x plus 1 instead of 1 plus x. Totally fine.
Oh no, this domain.
Domain.
Another.
Oh, no. Domain. Okay, guys. Domain. From the end, what do we know x cannot equal?
5/3.
5/3.
5/3. Okay, then we have to go back to the beginning. We care about the inside function, the g of x on this one. If you forget that or can't remember why, just look at your first step. What can x not equal out of this first step?
3.
3, right? And that comes from that g of x function. It's always going to be whatever the inside one was. So look at your first step, look at your last step, and you can get all your domain restrictions. So make sure you write your domain in order. 5/3 is smaller than 3, okay?
Oh, you were
Yeah?
Yeah.
Okay. Why is it what? So look at your very first step. Is -2 going to cause me any problems? Cause me any problems? Like make a 0 in a denominator anywhere?
Well, it's not even zero.
In f of x, yeah, but what about the first step of my composition here? Do you see how the 3 is going to cause me problems?
Yeah.
Negative 2 isn't. Yeah, so that's what I'm talking about. It's always the inside function that we pull our domain restrictions from first. Yeah, because the outside one, you're completely changing, so it doesn't matter.
Is it possible though for that something like you have three, like I wouldn't say 3 different axioms? Is it possible to have that?
Oh, yeah.
And each one has there's like 2 lines that like the 3.
Yeah, when we graph our rationals, I won't have you graph things that are like that, but do they exist? Oh, dear.
It jumped, I swear.
All right, we okay on 4. Anybody need another minute on this one? Are we ready for inverses next? I see some people still writing, guys, so I'll wait here a second.
I didn't say that.
Good? Questions or you're good? Okay. Inverses, guys. Inverse functions. All right, some key aspects of inverse functions. The x and y are switched. You guys remember that? Anybody remember what line we reflect across graphically for inverses? Yes, exactly. Reflect across y equals x. And then we have this thing called 1-to-1. Both the original and inverse are functions. Check. Is vertical and horizontal line test. I'm going to draw a couple functions here, and you guys tell me if they are 1-to-1 functions. And I'll explain if you're like, I have no idea if they are one-to-one. Are you saying no to both or no to the first? What do you think, guys? Do you agree?
Thing, and it goes through it more than once.
Good job. Yes.
I remember
The thing. The horizontal line test. Yes. You guys know the vertical line test to see if something's a function. Both of these are functions. The horizontal line test, if it touches it more than once, not one-to-one. What about the second one? Yes, one-to-one. Simple, but I want to make sure you remember. Okay, I think I'm on number 5, but I don't remember. Is it 4 or 5? What number am I on, guys?
5.
5.
Wait,
5, 9.
Yeah, you're on 5.
Thank you.
That's a good.
The only thing I have to remember.
See, you can track my numbers. That's good.
I think you did.
Almost like a kindergarten.
You can count. Woo! All right, are f of x and g of x inverses? And I want you to prove this.
oh, this is where you.
Plug into each other and see that.
Yes! Good memory. Okay. Well, that's okay. All right. No judgment here. All right, so you are given f of x equals 2x minus 6, and g of x equals 1/2 x plus 3. Okay, proving whether or not these are inverses is where you have to use composition of functions. You have to show f of g of x, and you have to show g of f of x. And if they both simplify to no x,
They equal each other.
no, if they simplify to x, yes, then they are inverses.
Yeah.
Why would you plug each other in?
All right, so let me go through f of g of x. So we practiced composition already. I'm plugging it in. 2 times the quantity. 1/2 x plus 3 minus 6. And yes, guys, you have to show your work. Show me that you multiply.
No way.
It is true.
X plus 6 minus 6.
They're inverses.
That one's x. We have to check the other one too. Now, guys, if you do the first one and it's not x, you don't have to do the second one. You can just say right there, hey, these are not inverses, okay? And hopefully you didn't make a mistake in your math. Yeah, man.
I like swapped the x and the y and then solved for y.
You would not get credit for that. That is a way to find an inverse, and we're going to do that. But that is not the only way to prove it is with composition.
So I could do it just to prove it. But it would be easy to just do the theory part.
Yeah, because you have to do that to get the credit for it. Okay. You think you got it? Okay. All right, I'm going to write, but you just don't have to look. Okay.
Yo, I did it. Yo, X. Okay, wait, can I explain it? Alright, so start with like half, and then in the parentheses 2x minus 6 plus 3.
Yes?
And that turns, because like half of 2x is x, half is minus 6 is minus 3,
Yep.
and minus 3 plus 3 is 0.
Good job.
So it would just be x.
Yeah. Okay.
It's definitely not because solved for it.
All right, and then we're going to say, therefore, f of x and g of x are inverses. Don't forget this last step of actually saying, yes, they are inverses.
So did I prove it correctly?
Good job. Yes, you did.
So can you give me that?
No, not how this works.
I think we should just give 3 A's out on Halloween instead of getting us candy.
I don't think we have school on Halloween, so.
Yeah.
Really?
The math department looks ahead at these things, you know.
We don't have school on Halloween.
I don't think so, because I think the quarter ends on like the 29th or something, or 28th.
There's
We always have school.
Yeah.
I'll pull up the calendar. I don't think so. All right, guys. One more example, and then I have a little practice problem you're going to do for me, okay?
Okay.
One more in the notes. Whoa.
Wait,
Yes.
how many more questions are there?
What?
How many more questions are there?
One in the notes. And that's it. We're going to find the inverse. So, Maddie, this is what you were trying to do, okay? Y equals 3 plus x. That is absolutely right for finding the inverse, not for proving inverses. It's all in the wording, guys. Oh.
I plus X, I started writing, so I figured that was it, and then I look up.
There's more.
All right, guys, if we are finding the inverse, step 1, switch the x and y. So I have x equals 3 plus y over 2 minus 3y. Am I done? No, what am I solving for? Y. Oh, there's 2 of them. Now what? Do we just go cry? Is that where we are?
Yes.
All right.
Funny.
We want to get that 2 minus 3y out of the denominator. So how do I do that? Yes. Magic. Right.
Oh.
So these cancel. I'm going to go ahead and distribute over there. So I'll have 2x minus 3xy equals 3 plus y. There are still 2 y's. So remind yourself on this step, what am I solving for? Y. So I want everything with a y on one side, everything without a y on the other side. So I'm just going to move things around here. So I'm going to have negative y minus 3xy equals 3 minus 2x. You certainly could have moved things to the other sides and you just have opposite signs. That's fine. What can I factor out of the left? Y. You could do negative y. Let's just do y, though, because y is what we want to solve for in the end. So just pull out a y. What would be left in parentheses? Yes. So how do I get y by itself? So we have 3 minus 2x over negative 1 minus 3x. And again, if you have completely opposite signs, that's fine, you did it right. And since this is the inverse, technically we'd say inverse of y equals that, okay? You don't do that all the way through, but just your answer at the end. Okay. Did I? If I'd started with f of x, but I started with y. So you're right. Okay, did I lose anybody in the middle of that one?
I need a second.
Need a second? Okay.
If you move the 3 to the left side and try to factor it, you could because it wasn't right. Or you could move back to
If you left the 3 over there,
the
but it doesn't have a y.
yeah.
Right.
Correct.
Correct.
Let's say,
All right, any questions before we do this practice problem? Okay. I've got it copied for you, so don't start writing this down.
What is that?
It's definitely
So how many people dropped out of your class?
That's true.
Just wondering.
It's theoretical.
You saw how many, like, genuinely, how many people dropped?
Yeah, you agree?
In all, how many so far? How many so far?
Last year I had a few more just because of the like return purple. This was
In all your classes?
You probably got
But, honest question.
per class. If you switch the house, right, you're gonna have this.
probably 1 or 2 per section. So it varies. So sometimes it's none in one section, or like 3 in another section. It also depends on what people think. Like, some people try to do honors pre-calc, and that's the bigger jump than the. It's like, I got to drop out of history. How's history going?
Wait, how many people dropped out this week?
None in here. Because his schedule just changed and he's now in the other honors class. So no one in here.
Okay, so who would like to go with you? Someone do it before. Who would like to go with me?
Someone do it before he does it himself.
Are you feeling overwhelmed?
No.
Oh.
Yeah. I'm not overwhelmed. I'm submitting all my work at like midnight because like I have so much computing.
Okay, so it's more like your overall schedule is a little much.
I have 26 tests tomorrow.
Good job. Okay, guys, we have 15 minutes left. Let me get through this with you. It looks scarier than it is. It looks very
It definitely looks scary.
Yep. Okay. The first one here, I've given you this function f of x, and it's literally just 4 points. That's it. It's 4 dots.
So you can just use those domains.
Right, so what is the domain?
This domain would be the lowest, or the
-2.
the lowest number.
Yeah.
4.
Is it everything, -2 to 4?
No.
No.
just like it's too.
It is just these individual values. That is it.
Because they're points.
They're just points. Yeah, this is not a line of any sort. It's literally dots on a graph.
How do we live?
Because they're listed as individual ordered pairs, yeah, that's the point -2, 1. And then it's not like an interval from -2 to 1, from 1 to 0, nothing like that, okay? All right, so what is the range of f of x?
0, 1, 2, 7.
And I don't care if you put it in order or not. Does not matter to me. If that makes you happy, then do that. Otherwise, I don't care. We'll get there. Okay, g of x, domain.
Zero, 4, 5.
Okay. Range. Clearly, it does not make me happy to put them in order, so.
No.
What?
Literally should
Call
call.
Nope, gotta keep moving.
Coins.
All right, f of x plus g of x. We know how to add functions when it's like an equation, but yeah, it's a little weird when you just have points. So what you have to do is look to see, do any values in my domain overlap? If they do, then I can add those y values. So let me show you the first one, and then we'll get to practice it. So f of x plus g of x. So I look at f of x. I have a -2 here as an x value. Do I have a -2 as an x value in g of x? Yes. So I know I'm going to have the point -2 something. I then add the y values because that's the operation we're talking about here. So what is 1 plus 3?
4.
Good job.
Actually, I think it's 5.
All right. Then I go to the next point. I have an x value of 1. Do I have an x value of 1 in g of x? No, so I can't use that point. I have an x value of 3. No, I have an x value of 4.
Yes.
Yes, so I'm going to have the point 4 what? Yes. Now, we could write the domain and range of that new thing, but it's very repetitive to just keep doing that. I think you get how to do domain and range from ordered pairs, right?
We don't do any of the other things.
No, because they don't match. They don't line up, so you can't add their y values. Yep. Okay, so f minus g. We already know that there's only 2 x values that match up, right?
Yeah.
We're going to just use those same points then. So f minus g, I know I have -2's that match. I have to then go and order f of x minus g of x. What do I get for the y value? -2.
Yeah.
Okay. And then the other point will be for what? 9. Yeah.
Wouldn't it? No. Because 2 negatives equal positive.
Yes, they do. Okay, let's do.
That's kind of the speed of that.
Yeah.
What's the actual?
Yeah, if you list it, it'd be -2, 4. Okay. All right, f times g. Again, I know I'm starting with that point with the -2. What's my y value?
That's 3.
3. And then 4 what? Yes, good work. Okay, let me stop here for a second. I want to make sure I'm not rushing you guys through it. You can do the domain and range. It's the same here.
Not the FOG.
Yeah, those are going to be trickier. Let's do division first. Okay, so again, I start with the -2. Yes. 4, -7/2. Okay, now guys, what would I need to be cautious of when I'm doing the division one? No? What's a concern only with the division? Yeah, what can I not divide by? 0. So if I ended up with like 7/0, you just wouldn't include that point because that doesn't exist. Okay? All right, we'll list this one more time. Okay. The f of g of x and g of f of x. It's a little weird.
Oh, wait, is this?
It's my markers. Maybe. I need a living marker, guys. Again, marker is so sad. Please bring me markers.
Sorry.
Don't steal, just donate. Okay. F of g of x. Guys, you have to pay attention to this. It's not hard once you see it, but if you don't pay attention, you're going to look at it and go, huh? So we start on the inside. So we're going to start with the g of x function. So I'm here. The input of -2 gives me an output of 3. Okay? I take that 3 then into the f of x function. Is there an input of 3 here?
Yes.
Yes. And what is that output? 2. So the point, original input, final output. Okay? Again, not bad, but kind of looks like wizardry, so. Next one. 5 gives me 1. Starting with that g of x again. Is there a 1 to give me something in this?
Yes.
What does it give me? So what is the point here? 5, 0.
5.
We see it? We're going to keep doing it. Original input, final output. Original input was 5.
Oh, we're doing it for every single point.
Yes.
Okay.
All right, 4 gave me a -2. Is there a -2 to give me something? Yes. What does it give me? So the point here is 4, 1. And then what's the last one? 0, 7. Again, I don't think it's bad once you see it, but initially you're like, what are we doing? Yeah. Okay, so then let's try g of f of x. So where do I have to start this time? F of x. So -2 gives me 1. Is there a 1 as an input? No. So I get nothing. Okay. What about 1 gives me 0?
Yes.
0 gives me 4. So that is the point 1, 4. Are you guys with me?
Yes.
You see it? Okay. 3 gives me 2.
No.
No.
Flip.
4 gives me 7.
Not.
Nada. That's it. Okay.
One.
Could be no points.
That's the entire function.
So based on what
It's 1 dot. Oh, that's it. Yeah.
Is there a reason why there's a 0.41 and there's another 0.14? Is that it's just like,
It just is. It's how it worked out this time.
it's just coincidental?
Okay. Questions. All right. I don't think I've made your math space available yet, so let me do that real quick. Math space. It's coming. Right. Oh, sure. Always. Okay, guys, it's there now. So make sure you're staying on top of your homework. Look at Schoology for some of the extra practice. The math space is not completely basic, but it's kind of just like, okay, can you do these topics? The paper part of your test, you're going to have to be able to like put it together, like things like this, okay? So your assessment, guys, it's got 2 parts. It has a math space part, and then it has like a paper pencil part. Okay? The math space is like gets you to a C, and then the paper part is where you get an A or a B.
Look, there's stickers in my notebook.
It's exciting.
Mine's like
And then 4. You just use the -2 on that. Or 1. And then 0 to 4. 0 to 7. Okay, and then with this, you get 2, 5, 4.
I told her she stressed me out.
And with the Y, 2, 0, 1, and 7.